An inductor 20 mH, a capacitor 50 microfarad, and a resistor 40 ohms are connected in series across a source of EMF voltage V is equal to 10 sin 340t. The power loss in AC circuit is. Okay. So we'll see here the diagram. See, this is a circuit diagram. The inductor, that is a 20 mH, and it is connected, all these are connected in the series. Next it is capacitor, that is 50 microfarad, and a resistor, that is 40 ohms. Okay. And the voltage supply here, it is equal to 10 sin 340t. Okay. Then what is the power loss in AC circuit we need to find here? Here we know that is a XL, that is equal to omega into L, which is nothing but omega is equal to, that is they are given, that is a 340 into L is, that is a 20 into 10 to the power of minus 3. We get the answer, that is a 6.8 ohms. Then XC is equal to, that is 1 by omega C. 1 by omega C, which is equal to 1 divided by 340 into 50 into 10 power minus 6. So by simplifying, we get the answer, that is 10 to the power of 4 divided by 170, which is equal to, that is 1000 divided by 17, which is equal to 59 ohms approximately here. 58 point something, 59 ohms. Then we can write this one as under root of 40 square plus 58.8 minus 68 whole square. Then we get the answer, that is 1600 minus 52 square. Then P average, that power average, P average is equal to VRMS into IRMS into cos of phi. If I'm going to substitute the values here, that is then VRMS into VRMS divided by Z into R divided by Z, then which is equal to VRMS square divided by Z square into R. By substituting the values, we get 10 square divided by under root of 2 whole square divided by 40 square plus 52 square into 40, which is equal to 4000 divided by 2 times 1600 plus 2704. We get the approximate value, that is 0.46 watts. But here the closest answer for this one is 0.51 watts. Option A is the right answer.